In the last video, we built a baseball team class. Now we need to have a class to handle football teams as well. One solution is to duplicate the code. I could copy and paste the baseball team and rename everything for football team and create a football player as I'm showing on this slide. This means I'd have to make sure any changes I make to one team or player that made sense for the other team and player had to be made in both sets of code. This is rarely a recommended approach unless team operations are significantly different. The second solution is to use a player interface. I could change baseball team to simply team and use an interface type or either an abstract or base class called player. On this slide I show a team class, and on this class the members are a list of players. I've made player and interface and have baseball player and football player classes that implement that interface. This is a better design than the previous one, but it's still got problems. Let's explore it a little in code. I'll start by copying the baseball team class. I'll paste it and call it sports team. I have a team, but the type of element in the team is still baseball player. I could make an interface called player and use that. In fact, I'll do that next and just add that interface in this main.java file above the baseball player record, interface player and left and right curly braces. I'm not going to add any methods in this interface. The reason I'm using an interface here is simply because my baseball player is a record and records can implement interfaces but can't extend classes. There are other reasons to use an interface, especially if you have methods you want implemented, such as rank, best player, or something along those lines. I'm going to use IntelliJ's replace feature on my sports team class and replace every baseball player with just player. I'll select replace all. Going back to the baseball player record in main.java, I can just add an implements player to that record now. This is one advantage to using an interface over an abstract class. Interfaces work with records. At this point I have two classes that can work with baseball players, the baseball team class as well as this new sports team class. Going back to main, I'll copy those first three statements and paste them right below. I want to change those first variable names to be Phillies1 and Astros1. I'll change Phillies to Phillies1 on the first statement, Astros to Astros1 on the second statement, and the same for the third statement. I want to leave this code here for you if you want to come back and explore it later, but the rest of the code will use the new Phillies and Astros teams. I'll change baseball team to sports team in those two statements. This means our Phillies and Astros teams are sports team instances and not baseball team instances. Before I run it, I want to copy and paste score result, changing the parameter types to sports team. This creates an overloaded method. So now my code compiles and I can run it. And the results are the same, but now with this new class sports team, I can create a football team with football players. Let me do that now. I'll create football player in main.java by copying the baseball player record and then changing that to football player. And football player will also implement player. Going back to the main class, I can create a new team with football player. Sports team AFC equals new sports team with Adelaide Crows as the argument. var tex equals new football player passing Tex Walker as the name and centre half forward as the position. I'll call afc.add team member passing Tex. And finally I'll call afc.list team members. I'll execute this now. The output shows the Adelaide Crows football team members printed out with a single member right now. This was one solution. I created a team that has a list of players, and as long as I have our classes or records implement the player interface, I can use this class. That's all well and good. I've got a team that will support any kind of player, but this team has a problem. Did you spot the problem? First, there's no type checking when it comes to team members. Let me show you an example of what I mean. var Guthrie equals new baseball player with these two arguments. And I'll add that player to the team. Here I'm adding a baseball player, a Phillies centre fielder named D. Guthrie, to my Adelaide Crows football team, and the compiler lets me do it. Running that now to review the output. You can see that on the last line, our Adelaide Crows team, supposedly an Australian Rules League football team, has a football player and a baseball player. This is almost certainly not what we'd want. We could leave the rules up to whoever is writing the code, or we could build in some rules. Generics give us a better solution by allowing us to create a generic team class which has a type parameter. Let's see what that would look like. I'll copy the sports team class and make it truly generic. I'll call the copied class team. Now I have an exact duplicate of sports team except the name. The first thing I need to do to make a class generic is to set up type parameters. I've already shown you that one way to declare a generic class is to include a type parameter which I show here in the angle brackets. Now using T is just a convention, short for whatever type you want to use this team class for, but you can put anything you want in there. Single letter types are the convention, however, and they're a lot easier to spot in the class code, so I encourage you to stick to this convention. You can have more than one type parameter, so I could have T1, T2 and T3, etc. Convention says that instead of using type parameters like this, it's easier to read the code with alternate letter selections, and these are usually S, U and V in that order. So if we had 3 types, you'd probably want to declare this class as shown here, with T, S and U. A few letters are reserved for special use cases. The most commonly used type parameter identifiers are E for element, used extensively by the Java Collections Framework, K for key, used for mapped types, N for number, T for type, V for value, S, U, V, etc. for second, third and fourth types. Getting back to our generic team class, I'll add the type parameter angle brackets with a T inside after the class name. That's our first generic class team with one type parameter. Remember that this class is dealing with player instances predominantly as the team members. So T, in the cases we've been looking at, would really stand for player, either a football player or a baseball player. I want to replace any reference to the player class, paying attention to exact match on case, and change them to the type T. And I'll do that with find and replace and change every reference of player to just T. This changed our list to have T in its angle brackets. And the add team member method was changed. The type of the parameter is T. The parameter name is also an uppercase T, and that can be confusing, so I'll change it to a lowercase t. And that's our first generic class completed. I'll switch back to the main method, and similar to what I did before, I'm going to copy the 3 statements, starting on line 15, and paste them right below it, starting at line 19. I'll rename Phillies to Phillies 2, and Astros to Astros 2 for the first set of sports team statements. And then in the pasted statements, I want to change sports team to just team. And again, I'll make a copy of the score result method and change the types to just team. This code compiles, but it's got warnings. I'll come back to the warnings. I can run this code now. I get the same results for all of these types of team classes. Leaving it this way in the code means we're really implementing it with the raw use of the class. When you use generic classes, either referencing them or instantiating them, it's definitely recommended that you include a type parameter, but you can still use them without specifying one. This is called the raw use of the reference type. The raw use of these classes is still available for backwards compatibility, but it's discouraged for several reasons. Generics allow the compiler to do compile time type checking when adding and processing elements in the list. Generics simplify code because we don't have to do our own type checking and casting as we would if the type of our elements was object. You may forget to include the type parameter, but IntelliJ will try to identify this for you. As you can see, IntelliJ is warning us with the yellow highlights that there's something we might want to review in this code. Let's change the code in our main method to include type parameters for our 3 new statements. I also want to go down to the Adelaide Crows team on line 29. I'll copy and paste that statement and do something similar, renaming the sports team AFC to AFC1, and then changing sports team to just team on the pasted code. With these changes, Notice that I've now got a compile error on line 35 where I'm trying to add D. Guthrie, a baseball player, to the Adelaide Crows team. This is actually a good thing because the compiler is now ensuring our teams have the same kind of player. Let me move Guthrie up. I'll cut and paste him after the other Phillies players. So after Marsh on line 27. And I'll create another football player. var Rory equals new football player, and the name will be Rory Laird and position of midfield. Invoke afc.add team member to add the player to the team. This code compiles, so let's run it. We now have the correct baseball players and football players in each list. Maybe you've noticed that in the main class, IntelliJ has been trying to get our attention on that last score result method. So far I've been ignoring that. The warning is about the raw use of the parameterized class team. I'm going to continue to ignore this warning as I work through the rest of this example. Generics can be tricky when they're used in method parameters, and the rules are different for a static method versus an instance method. I want to cover these rules thoroughly in a future video. For now, I'll leave my code with these warnings as we learn the basics of creating a generic class. I want to end the video here before it gets too long. In the next video, I'll discuss using multiple type parameters and applying something called an upper bound on a type parameter. I'll see you in that next video.